Okay, so keep in mind when you are simplifying with I is the square root of -1, okay? When you're simplifying, you simplify just like you would normally, except when there's a negative number under the radical, and I will be included in your answer. So how this interprets is you can break this down into the square root of -1 times the square root of 9, because remember, you can multiply those two things and get what's under the radical, okay? And anytime there's a negative number underneath the radical, you can break it up into root -1 times root of whatever the positive value that's under the radical. So then the square root of -1 is I. Okay, this is a factoid you need to have memorized. The square root of -1 is I. And then the square root of 9 is 3, so I times 3, and typically how we write this is 3i. Okay. This one, you can break it up into root -1 times root 48. Remember, when you're simplifying a square root, you're looking for the biggest square, perfect square that's a factor of that number. So 48 is 16 times 3. So this you get I, this you get 4, this you get root 3 because it's not simplifiable. Typically how we would write this is 4i root 3. And then lastly, you only have to simplify that piece. So remember, this is root -1 times root 18. Root 18 can be split up into root 9 times root 2. So this piece, I, this piece, 3, that piece stays the same. And the cleaned up way that we typically write that is 3i root 2. Okay, remember, you cannot combine here because one has a radical by it and one does not. Okay, so when you're solving using square roots, so actually we're going to compare and contrast first. So we have two ways to solve this. One is by factoring. So remember, when we were factoring, we always had one side equal to 0 first. So I would move the 36 over. Okay, move that over. When you were factoring, you always had to have one side equal 0. Then you factor this. This is a difference of squares. You need factors of 36, -36, excuse me, and the outers and the inners cancel each other out. So when you FOIL that, you get x squared plus 6x minus 6x minus 36. And these will cancel out, so I'm just showing you why that's the factorization for that thing. Now individually set the factors equal to 0. So you get x equals 6, x equals -6. Two solutions there. Okay, well, we have another way to solve problems like this, and I covered this for a second on the front page. It's called the principle of square roots, and we use this method all the time in Math 180. So instead of bringing 36 over, you can just look at this and take the square root of both sides. So the square root of x squared is x, and this would be plus or minus 6. The reason why is because if you look at the original problem, there are two values that work in here for x. 6 squared is 36, and -6 squared is 36. So you have to do plus or minus when you take the square root of both sides to solve an equation. This is really important. If you take the square root of both sides to solve an equation, you have to do plus or minus, because if you go back to the original problem, there will always be two things that work in here for x. In this case, it's 6 and -6. A common mistake is to forget the plus or minus when rooting both sides to solve. This is really important. Don't forget it. And a lot of times I will encourage people to go back here and solve it this way, because then you always get the plus and the minus. Okay, but sometimes people will forget it here. So let's look at the reminders. Common mistakes to avoid. Do not forget to include the negative square root in the answer. That means you have to do plus or minus when you root both sides to solve, because without the plus or minus, you're missing half the solutions because it only means the positive one. Oh, and make sure when you're solving that you either isolate the squared term or the squared quantity. So we're going to go through and solve a bunch of these by using the principle of square roots. This is a really important idea for Math 180. So you always want to isolate either the squared term or the squared quantity. So that's talking about that thing. So if I'm solving this by the principle of square roots, I'll start by moving over 240. You want to isolate the squared term or the squared quantity. So you want to isolate that thing. So then I will divide both sides by 6 to get rid of the 6. You want to isolate the squared. You get 40 here. Okay? Well, now you're in a position where you can take the square root of both sides. Okay? Again, let me just remind you, you want to isolate the squared term or the squared quantity. And then you can take the root of both sides. Okay? You will simplify that like we have been doing. It's the square root of 4 times the square root of 10. Looking for the biggest perfect square, that's a factor. Plus or minus, always. Always, you guys. So that's 2. So your answer will look like this. And that's it. That means 2 different numbers. It means 2 root 10 and negative 2 root 10. It's the two of them together. You can separate them out if you want, but you can have it written compactly also. Okay, so isolate the squared term always. So subtract 4. Divide by 9. Do not panic because it doesn't divide evenly. Okay, because the nice thing about this is that those are both perfect squares. Okay, so isolate the squared term first. Now take the root of both sides. Okay, so you can simplify this into plus or minus always root 64 over root 9. Oh, excuse me, root negative 64. So square root there is 8i. You need an I in your answer because there's a negative under the radical. So final answer, plus or minus 8i over 3. The reason why that works there, you guys, is because you can break it up into root negative 1 times root 64. So I can take the square root of that, it's 8. Take the square root of that, it's I. Plus or minus always. Okay, so now in these two, we have a quantity squared. So the quantity squared here is isolated, so you always want to isolate the term that's squared or the quantity that's squared. So when it's different when it's a quantity, because when you look at this thing, you could just take the square root right here. So then you need to be thinking about what happens when you take the square root of this thing squared. They just cancel each other out. So you get x minus 3 equals plus or minus root 12. Okay, so you need to simplify that. Its perfect square, that's a factor, is 4. So plus or minus 2 root 3. Remember, what are we doing here? We're solving for x. So the last step is that you have to bring over the 3. You cannot combine these because one has a radical by it and one doesn't. Okay, so you just leave it that way. You can't combine by adding or subtracting. Okay, remember this represents two answers, 3 plus 2 root 3 and 3 minus 2 root 3, which if you type those into the calculator, you can get some decimal estimates. You'll notice that they're two distinctly different numbers. And then the next one. So it has the quantity squared isolated. So you can start out by taking the square root of both sides. Here, it's just the square root of something squared, so they'll cancel each other out. So you have 3x plus 1 equals plus or minus root 15. Do not forget the plus or minus. Don't forget the plus or minus. Okay, so root 15 is not simplifiable because it's just 5 times 3, and neither of those is a perfect square. So what you would do is bring over the 1, subtract 1 from both sides. It's going to look like this. You cannot combine those by adding and subtracting because 1 has a radical with it and 1 doesn't, and then divide by 3. We use this method all the time in Math 180. This means -1 plus root 15 over 3 and -1 minus root 15 over 3. Okay, you could also break it up into this over this and this over this if you wanted. Okay, two distinctly different numbers if you type them into the calculator and get a decimal estimate. Okay, so quantity squared is isolated. So you can start off by taking the root of both sides. This is plus or minus root -24. Okay, so you can simplify this. There's a lot here, you guys. It's root -1 times root 24. Root 24 can be simplified by breaking it up into root 4 times root 6. And probably a lot of you can go straight from here to maybe the simplified version. So that's 2. This is I, and that'll just stay radical 6 because there's no other perfect squares that are factors there. Okay, getting a little sloppy with my work here. Move over the 5 and divide by 2. So you get 2x equals 5 plus or minus 2i root 6, and then divide by 2. These are some interesting answers. If you want, you could break it up into this over this and this over this and then simplify with those two. Okay, so those will simplify only. So you get 5 over 2 plus or minus I root 6. Those will cancel each other out. They just give you 1 and 1. And it's x equals. This, breaking it down into this, that, and that is not required. Like you could stop and leave the answer here, and it's considered fully simplified. And then lastly, okay, quantity squared is isolated. Take the square root of both sides. You get x minus 5 here because it's the square root of something squared. This is plus or minus 4. Okay, the square root of 16 is just 4. Next step is that you would bring over the 5. So you would add 5 to both sides. Okay, watch this, you guys. On this, you actually have to go through and get numerical values because you can do these problems. So you get 5 plus 4 and 5 minus 4. Okay, so 5 plus 4 is 9. 5 minus 4 is 1. So the two solutions are 9 and 1. On all the other ones, you didn't have to take it that far because one piece always had a radical in it and you can't add. But here where you could actually calculate the numbers without using a calculator, you need to do that for sure. I'll be back with a third video.